Hello everyone. In this videos, we will be discussing questions from um, previous year questions from IAT and NEST. These two exams are really important if you want to get admission for undergraduate studies in higher, like in physics. And these exams are IAT, which is your ISER aptitude test, which will be conducted, I think, in June or May. ISER aptitude test. Then there is Nest, which is Nest, which is your sorry, yeah, Nest, which is your test for admission into NISER. Okay, NISER aptitude, NISER entrance screening test. Okay, so these videos will help you prepare for these two exams specifically. So stay tuned to the channel for like these kind of sessions. Okay. So the first chapter I'll be discussing in this session, series is your gravitation. So I'll be directly jumping to numericals. I assume that you have studied the theory, so I won't be going into theory that much because you already have studied theory in your 11th and also during your preparation. So I won't go into it that much. We'll directly jump into numericals, which will really help you in solving questions. Okay. So first question. Let's write first question. We're solving one by one. Okay. Have pen and paper. Don't just sit in the session. Have pen and paper. Okay. So first question: if the distance between the Earth, the distance between the, write the question also. It will help you. Like while you are revising, it will help you. If the distance between the Earth and the Sun, where half, where half its present value, the number of days, in a year would have been, the number of days in a year would have been dash. Okay. Option A 64.5, option B 129, option C 182.5, option D 730. Okay, please try this question. The distance between the Earth and the Sun were half its present value. The number of days in a year would have been. That means, for example, this is your Earth, this is your Sun. Okay, and their distance is usually d. So if the distance were half its present value, if the distance is shortened to d by 2, okay, if the distance is shortened to d by 2, so what will be the number of days in a year? Because your Earth actually revolves around the Sun, and how many days does it take to do one complete revolution? 1 year, right? 1 year means 365 days. So it takes 365 days to complete one revolution around the Sun. So suppose the distance during this time is d. Suppose the distance is now d by 2, and the Earth is revolving like with this. So how many days would there be in a year? Okay, that's the question. So please try. You have 2 minutes to solve this question. Please try. You can pause the video and try. I will be solving it. See, see. We know Kepler's law. Do you know Kepler's law? Kepler's law of gravitation. That is, if you say Kepler's law is T square is proportional to R cube. What is your T? T is your time period. What is time period? Time period is the amount of time required to complete one revolution. Revolution means, suppose Earth is here, it will take exactly 365 days to come here again. So that 365 days is your time period of Earth. Okay, so T is your time period. R is the radius. This is the R. This is the radius of this circular orbit. Okay, so T square is proportional to R cube. So I can write, can I write T1 by T2 whole square? is equal to R1 by R2 whole cube, isn't it? T1 by T2 whole square is equal to R1 by R2 whole cube. Okay. So we know T1 is your 365 days. Okay. T1 is 365 days. And what is R1? R1 is simply, let's take D. Okay. Okay. It's D. Okay, now what happened? Now what happened? Distance between the Earth and the Sun were half its present value. Half. Now, if it is half, that means R2 is now what? Half of the original one, that is D by 2. So, what will be your T2? Simple. Okay, so we'll just put the values here. So, 365 by T2 whole square is equal to D by D by 2 whole square. So 365 by T2 whole square is equal to DD cancelled out. This is 4 only. Okay. So 365 by T2 is equal to, this is square now. This will go to that side, become root over. So this will become 2. Okay. So T2 is equal to, if I take exchange the places, 365 divided by 2. That will be 182.5 days. Okay. Is it there in the option 182.5? Yeah. So option C. So that is the answer. Okay. So if you see, if the distance is shortened, then the number of days in a year is also shortened. Shortened, shortend means is decreased. Okay. Yeah. So this is the first question from gravitation. Is it all right? Okay. Next question. Question number two. Question number two. A simple simple pendulum has a time period T1, has a time period T1 when on Earth's surface, and T2 when when taken to a height capital R above the Earth's surface, the Earth's surface. Okay. Hmm. Where R is the radius of the Earth, where capital R is the radius of the Earth, capital R is the radius of the Earth. Okay. So the value of T2 by T1, the value of T2 by T1 is how much? Okay. So the option A is 1 is 3, option C 4, option D 2. Okay. So simple pendulum has a time period T1 when on Earth's surface and T2 when taken to a height R, where R is the radius of the Earth. The value of T2 by T1 is how much? Okay. So what does the question say? The question says there is a simple pendulum here. When on Earth's surface, its time period is T1. Okay. But when we take this pendulum to a height R, suppose this is a height R, where R is actually also the radius of the Earth. Okay. So when we take this pendulum to the height R, this time period changes to T2. Okay, because time period will change as we go up and up. Okay, right. So what will be the ratio of T2 by T1? That is the question. Here R is the radius of the Earth, and we have taken the pendulum exactly to a height which is also the radius of Earth. Okay, so please try. You have 2 minutes. You can pause the video. Okay. So if we try to solve this question, first of all, tell me what is the time period of a simple pendulum. Time period of a simple pendulum. Time period of a simple pendulum is how much? T is equal to 2 pi root over of L by G, right? 2 pi root over of L by G. Okay. Tell me what is value of G on the Earth's surface. Don't tell me the value 9.8. The formula for it. The formula for it is G is equal to what? Suppose I say G1. Okay, G1 is equal to G capital M by R square. This is on Earth's surface, because here your R is your radius when it is on surface, so the distance is actually R from the center. Distance is always taken from the center. Remember it, yeah. Distance is always taken from the center. Is always taken from the center of the Earth. From the center of the Earth. Okay, okay. So G1 is your G capital M by R square. When it is taken to a distance R, okay, taken to a distance R, that means what happens? G2, it will change. So Gm by, now what is the total distance? This distance is R, this is your R. So RR is 2R. So 2R whole square. So this becomes Gm by 4R square, isn't it? Okay. So G2 is Gm by 4R square. Okay. So write the first time period, that is T1 is equal to 2 pi root over of L by G1. T2 is, see, length will not change. Length of a pendulum won't change because we just moved it. So T1 by T2 will be 2 pi root over of L by G1 divided by 2 pi root over of L by G2. Okay. So 2 pi cancelled out. LL cancelled out. So it will be root over of G2 by G1 because G2 will go up, right? That is your T1 by T2. So G1 is how much? Sorry, G2 is how much? Gm by 4R square. Gm by 4R square. And G1 is Gm by R square. Okay, whole root over. Gm cancel out. R square cancel out. 1 by 4 root over. That is 1 by 2. So T1 by T2 is equal to 1 by 2. So T2 by T1 is how much? 2. Okay. So that will be the answer. Is it alright? Okay. That will be the answer for it. Okay, next question, question number 3, I think. Two bodies of masses. Two bodies of masses m and 4m are placed at a distance r, at a distance r. Okay, so distance r. The gravitation potential, the gravitational potential at a point on the line joining where the gravitational field is zero. This zero each. Okay. Options are 6 g m by r minus 9 g m by r 0 minus 4 g m by r. Okay, please try. Pause the video and please try this question. Two bodies of masses m and 4m. M and 4m. Okay. I placed a distance r. The gravitational potential at a point on the line joining the gravitation field is 0. Suppose, let me draw it again. M is 0, 4m is 0. their distance is r. There is a point P here, if you read the question carefully, where the gravitation field is 0. Okay, so this is the point P. We will suppose that the field is 0 here. Okay, the field is 0 here. So what is the question exactly? Gravitation potential is asked, where gravitation field is 0. So here gravitation field is 0. Okay, so gravitation field, suppose we denote it by F. So the field, suppose we denote it by E. E is equal to 0, gravitational field. Okay, Eg is 0 here. So what is the formula for Eg? Suppose this is R. So suppose this is total is R. This is X. This is R minus X. Okay, or you can take this is X or this is R minus X. No problem. R minus X. This is X. Okay, we have to calculate field at P. Okay, gravitation field at P because of mass M will be how much? Gm by Gm by did I did the right thing here. This is X, this is R minus X. Gm by same thing, it's just X square. For my convenience, I'm doing it. Then gravitation field at P because of 4m will be Eg 4m. That will be G into 4m by R minus X whole square. Okay. So the total gravitation field here is how much? Gravity field is 0. Okay. Total gravitation field is 0. So total gravitation field at P is 0. So we just add them and equate it to 0, isn't it? So Gm by x square plus G into uh, yeah, G into 4m by R minus x whole square is equal to 0. Okay. So Gm will go to the other side, 1 by x square plus 4 by R minus x whole square is equal to 0. Wait, no. We won't make it 0, wait. We just equate them. Because see, the net gravitation field at P is 0, right? See. The net gravitation field at P is 0. That means what? Exactly. Suppose this is you. Net force on you is 0. That means the force, suppose two people are pulling you from both sides. A is pulling you from this side, B is pulling. Suppose, so what does it mean? Means force by B on you is equal to force by A on you. That's why you are not moving, right? If both the forces are equal, then only you are not moving. So we will just equate the gravitational fields. So Gm by x square is equal to G 4Gm by R minus x whole square. Okay, Gm cancelled out. Gm cancelled out. So 1 by x square is equal to 1 by R minus x whole square. Okay, that will be, if I take the root over on both sides, 1 by x is equal to 1 by R minus x. Okay, is it right? Oh, there is a 4 here. Huh? So this will become 2. I took the root over on both sides. So r minus x is equal to, this is 2x. So r is equal to 3x. X is equal to what? R by 3. Okay. So x is equal to r by 3. That means this is your r by 3. This is your r minus r by 3. That is 2r by 3. Yeah. So the point is r by 3 distance from m and 2r by 3 distance from 4m. Okay. Now what is the question? We have to calculate the gravitational potential. Okay. Gravitational potential. What is the formula for potential? Potential formula is, what is it? There is a negative sign, g into mass by distance. Okay. So for gravitation potential for mass m will be how much? Minus gm by distance. What is the distance we found? R by 3. Okay. Let's put R by 3. And what is the potential for 4m? Minus g into 4m by What is the distance? 2r by 3. So this is your minus 3 gm by r. This is your 2 to cancel out. 3 goes up 6 minus 6 gm by r. Okay. So we have to find what? The total potential at P. So total potential at P is how much? V is equal to minus gm by, sorry, 3 gm by r minus 6 gm by r. We'll just add them. That means minus will remain minus. So that will be minus 9 gm by r. Okay, that will be the answer. Minus 9 gm by r. Yeah, this one. Right. Charger नहीं है charger. Okay, next question. Question number 4. The particle is moving with a uniform speed. Uniform speed in a circular orbit of radius r in a in a central force inversely proportional to inversely proportional to the nth power of r. Okay. If the period of the pendulum, sorry, the, the period of the rotation of the particle is t, then dash. Option A, t is proportional to r to the power 3 by 2. T is proportional to r to the power n by 2 plus 1. T is proportional to r to the power n plus 1 by 2. T is proportional to r to the power n by 2. Okay? Yeah. Let's try this question. Particle is moving with a uniform speed in a circular orbit of radius r in a central force inversely proportional to the nth power of r If the period of the period of the rotation of the particle is t, then dash. Let's try. Okay. See, according to the question, central force is given by what? F is central force is inversely proportional to the nth power of r. Okay. So central force Fc inversely proportional to the r to the power n. Okay. So Fc is equal to k into r 1 by r to the power n. Right. Hmm? Now, what is your formula for central force? If there is a circular motion, force formula is m omega square r. Okay. M omega square r is equal to k into 1 by r to the power n. So your m into 2 pi by t whole square into r is equal to k r to the power n. Okay. What is the question here? T dependence on r, right? So let's here just let's see. M into 4 pi square by t square r is equal to k by r to the power n. If I take r to the that side, so this is 4 pi square m by t square is equal to k by r to the power n plus 1, right? So now let's consider this as a constant. We just need the dependence. So constant gone. So t square is proportional to a to the power n plus 1, right? So t is proportional to what? R to the power n plus 1 by 2. Is it all right? Yeah. So this option, which option is this? Option C. Okay. T is proportional to R to the power n plus 1 by 2. Next question. Question number 5. If the angular momentum if the angular momentum of a planet of mass m planet of mass m moving around the sun in a circular orbit is L about the center of the sun about the center of the sun. Its aerial velocity is okay. So the options are L by m, option B 4L by m, okay, option C L by 2m, option D 2L by m. So these are the options. Please try this question. If the angular momentum of a planet of mass m, there is a planet of mass m, angular momentum is L. About the center of the sun, it is moving around the center of the sun. Its aerial velocity is. Okay, please try. Aerial velocity. Just think about it a bit. Just try. Pause the video and try. So Formula for aerial velocity, if you see aerial velocity, is actually dA by dt. Okay, the amount of area covered by that planet. Suppose this is moving like this. This is the sun. This is a planet that moves like this from here to here. So the amount of area it is covering through its motion, that is your area, by per time. That is your aerial velocity. Okay, so dA by dt. So dA by dt is the area velocity, and dA is how much? Can you tell me? dA is actually half r square d theta. Okay, so this is the formula you have to remember. Hmm. Half r square d theta. Okay, and so for dA by dt we need, right? So dA by dt will be half r square d theta by dt. Okay, half r square d theta by dt. All right. So what is d theta by dt? Can you tell me what is d theta by dt? Theta is your what? Theta is your angular displacement. Suppose how much angle it is, it's subtending at the center for the sun. That is your theta. That is your angular displacement, right? Theta is your angular displacement. Hmm. So what is your angular like rate of change of angular displacement is your angular velocity. That is omega. So d theta by dt is your omega, right? So we can put d theta by dt is equal to omega. Okay. So let's put it. So dA by dt is equal to half r square omega. Hmm. Half r square omega. Now we need what? We need angular momentum, right? We need angular momentum. Your angular momentum is L. Okay. Angular momentum is and L is your MVR. All right. MVR. MVR is also can be written as m r square omega. Hmm. And we have here dA by dt is equal to half r square omega. So what is r square omega? R square omega is your 2 dA by dt, because that 2 will go to this side. So 2 dA by dt. So in place of r square omega, just put it 2 dA by dt. So m into 2 dA by dt. Okay, m into 2 dA by dt is equal to L. We need what? We need aerial velocity, right? Its aerial velocity is, so aerial velocity is d by dt. So we need dA by dt. So everything you just take to the other side. So L by 2m is equal to dA by dt. Okay, so your aerial velocity is equal to L by 2m, which is our answer. Okay, L by 2m is your answer. So this is the answer, and this is in the option C. Okay, this is in the option C. So this is the way to solve this question. For this, you need to remember aerial velocity. You need to also remember the value, the formula for dA. Okay, that is your half r square d theta, because A is your what? Area for this one is half r square theta. So dA will be of course half r square d theta, right? Yeah. So you just have to think a bit. You just have to be a bit smarter to solve this question. All right. Yeah. Next question. Question number 6. Next will be your question number 6. If the radius of the Earth is r, if the if the radius of the Earth if the radius of the Earth is r, capital R, okay, then the height h, height small h, okay, at which the value of g becomes one fourth. The value of g becomes one fourth is, if the radius of the Earth is r, then the height h at which the value of g becomes one fourth is dash. So option A is r by 8, and option B is 3r by 8, 3r by 4, and then your r. Okay, please try this question. You have 2 minutes. You can pause the video. The radius of the Earth is r, then the height at which the value of g becomes 1/4 is. Please try. We have done this kind of question. So I'll just solve it. You can pause the video. So we know g is equal to what? Gm by r square, right? Where this m is the mass of the Earth, r is the radius of the Earth, and gh at a height h is equal to gm by, just add it, that height, okay, r plus h whole square. So if you see, gh by g is equal to how much? Gm by r plus h whole square will divided by gm by r square. Okay, gm cancelled out, r square by r plus h whole square. All right, yeah. And what is given in the question? The height. Okay, the value of g becomes 1/4. Okay, the radius of Earth is at the height h at which the value of g becomes 1. That means what? That means gh is actually become, it becomes 1/4 of g, right? So just take this ratio. We can write it as gh by g is equal to 1/4. So 1/4 is equal to r square by r plus h whole square, isn't it? Yeah. So if I take, if I do the cross multiplication, that will be r plus h whole square is equal to 4r square. That is r square plus 2rh plus h square is equal to 4r square, isn't it? Yeah. Otherwise, you can do one thing. Just take the root over on both sides. R plus h is equal to 2r. So if you take r to the other side, then it will be r is equal to h, isn't it? Oh, sorry, h is equal to r. It's same thing, but we need the distance now. So we need the height. The height h at which. So height h is what? R. Okay. That is the answer. H is equal to r. Is it alright? So write a homework. Question number 7. Homework. The value of g. Just a similar type of question. The value of g on the Earth's surface. On the Earth's surface is 980 centimeter per second square. Its value at a height. Its value at a height. Its value at a height of 64 kilometer from the Earth's surface. From the Earth's surface is dash centimeter per second square. Option A 960.4. Option B 984.9. Option C 982.45. Option D 977.55. Okay, please try this question at home. This is a homework. Okay, okay, that'll be it for today. We'll be solving. We'll be having more sessions on this type of numericals. Okay, thank you very much.